define a way in which you may have defined the scalar product of two vectors probably involves trigonometry and doesn't enter in the program. The scalar product, sometimes definition, the high school definition, or sometimes the basic physics definition, even at university, of the scalar product of two vectors is equal to the product of the distance of the vector from the origin times the cosinus of the angle in between the two vectors. So let me give two vectors. No. I'm not a here. This is A and this is okay. Okay, I have to recognize that my 7 years daughter is more artsy than me. Is artsy than me. Here, these are two orthogonal vectors. So you may want to check that A or an. If you've seen some orthogonality between vectors in high school, they find through the cosinus of an angle, you may want to check that the scalar product of these two vectors is equal to 0. Sometimes, remember, you will find this notation, some small arrow to denote vector. I'm not going to use the arrows at the vectors unless there is ambiguity about whether they are vector or they are a number. But I prefer to be as economic as possible with the notation. So this is for introduction. What was a module is what we will now call Euclidean norm of a vector. Its distance from the origin. That is a square root of the sum of the square of all coordinates, which is also equal to what? To the square root of A of the inner product of A by itself. So actually, there is a way of just a parenthesis. I will not ask you. And you will check that it will correspond to your, if you have done some trigonometry and some vectors, you will see that it will coincide with your definition of cosinus. What is a cosinus? Of the angle between two vectors. It's actually the scalar product of A times B, or the inner product of A and B, divided by the product of the Euclidean norms. This could be a definition. I'm trying simply to connect what with somebody knows. But there is another result, theorem actually, that this number is between 0 and 1. That the product of A and B, the inner product of A and B, is smaller or equal than the product of the norms of A and B for all A, B in Rn. So let's make some rain check. Here, we start from two vectors. I mean, these are introductory exercise or examples, just for you to get some glimpse of it. I will rarely ask explicit question about vectors. But this knowledge is necessary to understand decently linear systems and matrices as well. Matrices will be tools to represent linear systems. So let me write. We have first to compute the scalar product of U and V, 1 minus 2, 3, minus 1 half, 1 minus 1 half, and 3, inner product with 4, 4, and 2. Oh, let me remember you one thing, that from the definition of inner product, it follows directly that the inner product of two vectors is commutative, meaning the inner product of A and B is always equal to the inner product of B and A. Why? Because multiplication in R is commutative. Let me write just for the sake of it here. For all A, B in R and the inner product of A and B equal the inner product of B and A. I know it's straightforward. I know you understand it's trivial,